Our beloved viewers, I thank those that followed us in the previous session of equivalent sets and how to identify the equivalent sets from those that are not equivalent. Today, we are looking at another part of the set concepts, which is equal sets. We are to ask ourselves first, what are equal sets? And this is what we have to answer. Equal sets are sets which have the same number of members, and these members should be exactly the same. So equivalent equal sets are sets with the same number of members which are exactly the same. Exactly the same. I think we're going to get the meaning of this, of what I mean by exactly the same, along with the examples that we're going to see. Examples. Example 1. Set T equals to 2, 3, 5, 7. Then set K equals to 7, 3, 2, 5. So, given those two sets, we are to identify whether these sets are equal or not. First of all, we have two aspects in the definition of equal sets. The sets must have the same number of elements. That is what we should identify first. So I'm going to first get the number of elements in set T. So number of elements in set T equals to a high count. 1, 2, 3, 4. These are 4 elements. Therefore, set T has 4 elements. Then I also get the number of elements in set K. Number of elements in set K equals to a high count. 1, 2, 3, 4. They are also 4. That is one requirement which these two sets have met already. Then the other requirement to be met is that these sets must have the elements which are exactly the same. Let us see whether these elements are exactly the same. When I mean exactly the same, in other words, they must have twin elements. The twins which are identical. Yes, for example, if it is a 2, I also have a 2 here. Yes, meaning that this one is exactly the same as this. I have a 3 here. It is also exactly the same as this. I also have it that side. I have a 5 here. It is also exactly the same as the 5 I'm having this side. I'm having 7 here, which is exactly the same with the 7 I'm having this side. Therefore, owing to the fact that these sets, set T and K, have the same number of elements, each having 4 elements, and they have the elements which are exactly the same, we say set T is said to be equal to set K. Therefore, set K and set T are equal sets, since they have met the two requirements of equal sets. But we should have this to note as well. Note, equal sets are denoted with a symbol, the symbol is that. The equal sets are denoted with the symbol of the equal signs. So, having seen example 1, I think we can go about example 2 together. Let us try out example 2. Example 2. Under my example 2, I have set P equals to POTS and set J equals 1, 2, 3, 1, 2, 3, 4. Set P equals POTS and set J equals 1, 2, 3, 4. First of all, the first requirement is to first find out whether both sets P and J have the same number of elements. Number of elements in set P equals to 1, 2, 3, 4. The number of elements in set P is 4. Then number of elements in set J equals to 1, 2, 3, 4 equals to 4 as well. First of all, the first requirement is met of having the same number of elements. Then the second requirement, which we should all critically look at and take caution of, if these sets do not meet the second requirement, they will not be called equal sets. For example, set P has POTS and set J has 1, 2, 3, 4. Let us see if these members are exactly the same. If we have a P here we don't have a P. We have O here, we don't have O. We have T here, we don't have T there. We have S here, we don't have S that side, meaning that that requirement is not met. And owing to the fact that that requirement is not met, it means that these sets are not said to be equal sets. Therefore, set P and set J are not equal sets. Are not equal sets. They are not equal sets. But rather these sets are, since they have the same number of elements, however much the elements are not exactly the same. We looked at, in our previous lesson, we looked at sets which have the same number of of elements, and we call them we call them equivalent sets. Therefore, these sets are not equal since they don't have the elements are not exactly the same, however much they have the same number. But these sets are said to be equivalent sets. Now, if you understood the concept of equivalent sets, you will have passed this number, because these sets are not equal, but they are equivalent. Then we can have our last example, example 3. Example 3. ATS and set T equals to SATR. Set R equals to RATS and set T equals to SATR. So our first step to find, if we are to identify whether they are equal sets or not, we need to first get the number of elements in set R. Number of elements in set R equals to how many are they? 1, 2, 3, 4 equals to 4. Then I also find out how many elements are set T. Number of elements in set T equals to 1, 2, 3, 4. There are also 4 elements, meaning that the first requirement of having the same number of elements is met. But meeting the first requirement only does not qualify these sets to be equal sets, because we looked at the previous example. The sets, both sets met the requirement of having the same number of elements, but they were not treated as equal sets, since the members were not exactly the same. So owing to this fact that they have the same number of elements, they only qualify to be equivalent sets. But what makes them to qualify to be equal sets is to see whether they have if the elements are exactly the same. Let us find out. Do we have identical twin elements? We have R here. Do we have R this side? Yes, we have R. Not only having one element and you say, these are the same. No, you look critically at all the elements. Do you have A? A is here, and this A is the same as this A here. You might have A which is small, and that side you have A which is capital. Those ones are not identical. They are not exactly the same. If it is capital A this side, it also must be capital A the other what? The other side. That is what we call being exactly the same. We have T this side, we also have T this side. And the T is exactly the same as this. We have S this side, and we also have S this side, and the S is exactly the same as the S the other side. Therefore, set, owing to the fact that the elements are also exactly the same, having the same number of elements, set T and set R, set T and set R are equal sets. Equal sets. I can even use a symbol, set T equals to set R. So that is how best we can identify whether the sets are equal or not. And one thing to note, I think we are going to write it in our, you can note it in your head, that all equivalent sets are equal sets. Quote me right. All equivalent sets are equal sets. But not all equal sets are equivalent. You should note this. You should have it at the back of your minds that all as in the word all, equal sets are equivalent. I come again. All equal sets are equivalent. But not all equivalent sets are equal. Having put that at the back of your mind, I think you can go about this task that I'm about to give. So you can try out in your sitting room, having followed us. I think you can execute what you've learned today by doing these numbers. Thank you for following us. Thank you for being with us throughout the entire session. I think you can try out those numbers, and may God bless you richly and abundantly. Thank you for following us. Keep following us. You can invite a friend. You can invite a neighbor. We always have these online lessons on our YouTube channel posted. We also have them posted on our TikTok account. We are MME Math Clinic. Thank you.